Andreas, the founder and CTO of Silk Labs, who will be sharing with us his perspective on where visual intelligence should reside, whether it's in the cloud or the edge, or maybe a little mixture of the between. And Andreas is an experienced technologist and with a background rooted deeply in computer science. He is previously the CTO of Mozilla and wrote the first lines of code for Firefox. So he brings some deep technology experience to bear. And he leads the Silk Labs team. And I hope you can share a little bit more about that and the topic of edge or cloud.
Right.
Andreas, thank you very much for joining us.
Thank you very much. All right, great to be here today. Let me start with telling you a little journey how I got to do what I'm doing today. And I had a big transition in my career about 8 years ago or so from academia going to industry to Mozilla. And I recently made a similar switch for similar reasons. So I will talk a little bit about why I did that and what I found so fascinating about Mozilla. And I will try to use that to explain to you what I found so fascinating last year that I quit my job at Mozilla. I'm one of those weird PhD types who likes to do research. So Paul, I think, very accurately described most of us. We are in grad school, we like to hack on stuff, and it's exciting, and then all of us want to get some academic position, and we are very hard to remove from the safety of academia to be placed in the industry. Mostly because we are very shielded. Like, you don't really talk much industry in most disciplines, and you don't really know what's on the other side of the fence. It's very comfortable in academia, and there's great things and very interesting. So I was, until maybe 8 years ago, essentially on a lifelong academic track. I was 6 years old when I decided I want to be a professor. And I have been working on that very diligently. And then 8 years ago, I ran into Brendan Eich, the co-founder and former CTO and short-time CEO of Mozilla. And at this point in my life, essentially, I was working on systems and performance. I make stuff go fast. That's my particular discipline in computer science originally. And I was writing all these papers, and on a good day, hundreds of people would read my papers, which is very exciting once you get to write those things. And I ran into Brendan, and he asked me whether I would like to take the stuff I'm doing at academia, and instead of hundreds of people reading my papers, whether it would be interesting if hundreds of millions of people use the stuff that I do. And that was a trick question. If you're a PhD, anyone asks you that question, walk away, or you will leave academia. Essentially, I ended up taking the bait, and I came up here to the Bay Area for about 3 months. That was the plan originally. And I worked on not the very beginnings of Firefox, but the very beginnings of a fast internet, essentially, or a fast web. Back then, JavaScript was a very slow language, and I used my dissertation research to make it a lot faster at Mozilla. And I never managed to leave again, essentially. I literally just called the university, sorry, I'm not coming back, I'm going to stay here. And I did that because I realized how amazing it is that there's this amazing stuff happening on the web, and everyone wants to make it go fast, and I can participate in that. It was a big revolution for me to see all of a sudden the web turn from a place that shows you documents to a place that runs programs. The next 7 or 8 years I did Mozilla. I did a couple different things that are not too interesting. The last year and a half or so I was Mozilla's chief technology officer. It's one of the most awesome jobs in the world. You get to work on the web and all the things that I personally very much care about, which for me is security and privacy. I'm one of those people that would wear a tinfoil hat, except it's not very fashionable. And I got to work on the web, and every time there was a security problem for the web, I got to work on it and influence it, and especially as CTO, kind of steer a little bit the direction the web is taking by steering the way Mozilla would take a stance on these kind of positions. And at some point, working at Mozilla, I realized that a shift had happened that I barely noticed, where much of the things that could go wrong on the web that I so much enjoyed fixing, all of a sudden no longer happened where Mozilla really was focusing on. Mozilla is very much a desktop client-side technology company. And all of a sudden, a lot of the privacy and security concerns were no longer happening in the client. They were happening in the cloud. So these days, if your social security number is stolen somewhere online, it's usually not your browser's fault. And once I realized that much of this stuff actually is going wrong in the cloud these days, and Mozilla doesn't have a lot of influence over the cloud, I realized that I'm kind of working on the wrong thing. I will not be able to influence it much anymore on the client side. So that was the beginning of a journey for me that led essentially to leave Mozilla and found something else. And this something else is Silk Labs. And what we're trying to do is try to understand how we will architect the next generation of stuff that will connect us. It was the web for the last 20 years or so. We believe in a future where there's lots of connected devices around us. And we are very interested in understanding how data is being processed inside of that. And I'm trying to apply some of the things that I learned the last 8 years in that space. So what we're doing as a company is essentially, we are trying to help industry to make more intelligent devices. Everyone right now is selling you smart devices. And you go and you go in a Best Buy and buy yourself a smart light bulb. And a smart light bulb is a light bulb that when you come home, as it's dark in your room, you can take out your smartphone, you can unlock your smartphone, type in your unlock pin, find the right app, launch that app, wait for it to launch, and then you find the right button, you click the button, and your light goes on. Essentially, your smart light, we have invented a light that's like 6 steps harder to use than a traditional light bulb that Edison invented 150 years ago. So smart is being used today often to kind of like compare or really express connected, and connected by itself is not necessarily intelligent. So what I mean is intelligent is like I come home and when it's dark inside and outside my place, 100% of the time I want to turn on the light. And my light switch, the traditional light switch, learns that it's 0% of the time. Intelligent light is for me something that learns that. Like, yes, it's dark and he's here and it's him, he's authorized to be here, I should probably turn on the light. And this is actually well within what's technically solvable, but the industry that builds those things, like connected lights, who makes connected lights? Philips. Philips is not really a company that makes software or the necessary like machine learning, computer vision technology around it that knows how to make this really interesting. So that's what we are trying to solve as a company, essentially, make all the necessary pieces that goes in devices, in smartphones, in the cloud, to make all this stuff talk to each other. And when we created the company a little bit over a year ago, we had no idea just how deep that would take us into computer vision problems, and also, to a good part, applying the same technology stack to solving audio problems. And we learned a bunch of interesting things about pretty much the same problem that I left Mozilla over, like client, server, where do you do what, and how this kind of technology influences the way we will build stuff like this in the future. The original reason, I think, that we are seeing such a massive change right now happening in the way many things that we do around us will work is that there's 2 big disruptions happening, that each of which on their own would, I think, massively change the way stuff around us works. One is one that has been going on for at least 10 years, and somewhere there at the beginning of that curve is where at Mozilla I was always trying to make a smartphone operating system. Essentially, over the last 10 years, the way we compute has completely changed. Most of us grew up like with a keyboard and a desktop computer, and that stuff essentially is going away over a long enough time perspective. And smartphones have come in, and essentially there's already 2 or 3 times more smartphones out there per shipment than PCs. And it's a massive revolution that's happening right now that changes the way much of the technology around us will work in the future as well. To explain to you that, why I think that, who remembers here when the first PCs came out, like really at volume, and the stuff started scaling, when like everyone had one? Who remembers that? Do you remember the side effect of that? I remember when my parents got me my first PC, when I went to the airport, I could see like Windows something like on a airport monitor crashed. And it's very unusual, or ATM, same thing. You go to an ATM and like Windows is greeting you, it's crashed again. So it's like following you around. It doesn't just crash at home, it crashes on your ATM. And Windows wasn't used in airport monitors and ATMs because it's good. It was used because there's a huge supply chain behind it. All of a sudden, everyone wanted one of those things and made lots of them, and it made it very cheap to use it for other purposes. The same stuff is going to happen with all the stuff that goes into smartphones. Essentially, you will see, like, if you want in a couple of years, you build a tire monitor for your car. It's going to be a smartphone. It's not going to have a 3G modem and probably not a screen, but it's going to have many of the same connectivity and CPU technologies in there that a smartphone uses as well, just because you make so many of them. We make like 2 billion of them every year. So that stuff is very, very cheap. So this is one of the big things that's happening right now, is that all of a sudden compute is very ubiquitous. The smartphone supply chains make it very, very cheap to put it everywhere. And then second, over the last couple of years have been really scary advances in the way we can make sense with the computer of the environment around us. I pulled one of a random graph here on ImageNet performance. Essentially, we are starting to approach human-level recognition with deep learning in certain classes of problems. And these 2 things colliding together is very, very interesting, because each of them individually would really change the way much of the software we're building is being built. But now these 2 things happening at the same time, and they essentially create an interesting dot product, and that's a little bit what I want to talk about, and especially its implications on privacy. Now, the reason I think that the smartphone supply chain and that stuff being so cheap is so impactful, this is essentially we are in this unusual situation of technology, but maybe even like human history, where hardware has lapped software. Usually it's us software people who are like ahead, and we're like hardware people make faster hardware because all my Java code needs to run somewhere. And now it's the other way around. Any kind of IoT device, any kind of smart connected thing you could possibly think of, the hardware has already been invented. The hardware people have already done their homework. It's essentially available, it's performant, it's incredibly cheap. Let's say that you're working for Nest and you're asked to make a new generation of the Nest thermostat. What you do is you go essentially, I looked up on a Chinese night market, a cheap smartphone. This is a $25 LG smartphone. It has about 5 gigaflops CPU, 5 gigaflops GPU, about half a gigabyte of RAM, and VGA screen. Costs about $25. So essentially, you take that smartphone platform, you remove the square screen, you put a round screen on it, you take out the camera because Nest doesn't use a camera, and you kind of disable the radio modem, and there you go. You have a cheaper hardware platform than Nest is being built on right now. So essentially, this applies to everything else. Dropcam is the same thing. You would like to make a camera. Take a smartphone, take off the screen, take off the battery as well, put a round case around it. You have invented a smart camera. The difference is really just software. So all the hardware pieces have been invented. That's fantastic. And this is not just going to stop there. It's not just like we're going to make like more drop cams you can buy to record stuff in your life. This stuff is going to really become very ambient and disappear around us. So today, much of the video processing or video recording really, where we are right now technologically, is happening explicitly. I go in a store and I buy a camera, or I buy something else that has a camera-like product that I think about, and I go and buy that. The trend that's about, essentially a cusp of already, is that you see all these kind of like Teslas drive around that partially drive themselves. What people don't realize is that what you're really buying is just like a camera or multiple cameras that happen to have a battery and a wheel inside of them. The magic is not really the motor anymore. The magic is that we do all that vision stuff in there, and like we record video streams. And how does Tesla learn all that video feed data? Well, because they have access to like what your car learns on the street. So essentially, we're at a stage where people will soon no longer buy really cameras to install. You just buy stuff, and that stuff happens to have cameras in there, and it happens to record stuff. And someone somewhere is going to learn about that stuff, and you will still probably associate it with the camera. Like when you think Tesla, and next time you buy one, remember it has lots of cameras pointed at you that are recording you. So maybe don't go to your garage naked anymore, because God knows who's watching. But for a certain amount of time, you still have the opportunity to really like make a decision whether you buy this or not. I bet you in a couple of years you won't even have the decision anymore. This technology is becoming so cheap and so ubiquitous and so much better than alternatives that stuff like a smoke alarm, for example, right? How does it work? There's some isotopes being counted where the smoke is in between. Put a little video sensor in there. Put one of those cheap chips that we make with the smartphones right now, and you just turn it into a vision problem and see whether there's like fire. And you raise an alarm with that. So essentially in the future, it won't be even a feature of a product anymore. There will be just the cameras everywhere pointing at you and trying to make your life nicer and easier. But it has also certain implications. Now there's cameras pointed at you 24/7. You might remember maybe 2 years ago or so, Samsung got in the news because they have a camera and an audio sensor on a TV. And as it happens, they were recording you, and I think they were sending that unencrypted over to the cloud, if I remember correctly. So these things can very quickly turn very scary, and right now we don't really think about that, right? Like, have you ever wondered whether you should be having a confidential conversation about your company in front of your Samsung TV? Because I remember a couple months ago, Samsung was warning customers that they should not have confidential conversations near their TV, because they can't guarantee the audio being broadcasted out of there. So it's a very interesting scenario, and most consumers right now don't think about this. But I do think that they will, and I will try to explain to you in a second why I think that, and I have also historic evidence that they have done that. Now, the second piece of this, of course, is that we also not just gather all this information, but also we are starting to be able to make sense of a lot of this stuff. And that's, on one hand, a problem, but also an opportunity. Since I don't know exactly how much knowledge people have in the audience here, I will give you the 20-second tutorial on deep learning, because I will use some of the features from this slide in my later slide. Essentially, the idea of deep learning is that you have a pretty simple algorithm that with data you can compute, you can make it compute almost arbitrary things. All you need is like, you show it a lot of things, and you tell it what it is. So for example, you showed a lot of pictures of humans, and then the network is going to say, that's a dog. And you're going to tell the network, no, that's not a dog. Think about this problem a couple of times more, and then eventually it's going to learn, okay, this is what a human looks like, this is what a dog looks like. The training part needs lots of data and lots of iteration, millions of times, millions and millions of images to train the network. Once you have trained it, the actual inference step, where you ask the network, what is this? Only takes one single iteration and only one single input. So you give it a picture and it tells you what it thinks it is based on all the millions of iterations of training you have done before. The ability to do this at scale has really implications I think they're very hard to grasp. To use a metaphor for this, the notion of privacy is actually relatively new to human existence. A couple hundred years ago, privacy was not really a problem for you because we used to live in small little villages and like very few people were around us, and there was not really a threat that someone like would steal a social security number because you were like too busy to like, I don't know, like travel somewhere for a couple of weeks or like not get eaten by lions. So it's very much an artifact of modern society that there's concerns around privacy. And today we have a certain understanding of privacy. And there's a high chance if walking around the Hyatt here that there's some security camera pointed at you. We probably all kind of instinctively know that. However, much of that stuff is not really linked to the cloud, and there's not enough humans to stare at it to really track you 24/7. Or to use an even more extreme example, if you walk around in London, there's a very high chance that there's like cameras watching you, but there's not enough computer vision tech behind it just yet that someone can tell that, yeah, Andreas was like 2 weeks ago at 2:40 p.m. eating ice cream in London. But that's essentially where we're headed exactly with this technology. Now we have essentially an unlimited number of eyeballs. We can point at this stuff, and we can see what you do. We can track you everywhere, which is so foreign to us. It has never existed before. This was never a problem before. This is, I think, why many consumers don't realize that this is a problem. This kind of stuff that's becoming possible over the last couple of years in particular, and this deep neural networks has never existed before. Even me dealing with this technology now quite intensively every day, I'm sometimes still surprised by the stuff that's possible. It's going to take all of us as technologists a while to wrap our heads around it, and then it's going to take a little bit longer for consumers to wrap their head around it. Give you an example from daily life, and this is, I think, how consumers are going to start to find out about this stuff. There was a story a couple months ago about a product called FindFace. This was in Russia. They use a neural network that they have trained to distinguish pictures. The network essentially maps input pictures of faces you give it to high-dimensional space, and if it's the same face, the output vector tends to point in the same place in the space. What this allows you to do, essentially, you can identify someone. If you have a couple pictures of them, there's a high accuracy. You can go backwards. You can essentially show another picture, and you can tell who that person is. So they used the Russian equivalent of Facebook, and they identified people who are appearing in, I think, like some porn movies, I think, was the thing that really blew up on this one. And people just didn't know this is possible, right? So essentially, for like this industry has existed for a long time. These problems never appeared because it was infeasible to go through like 100 million profiles until now. And this is usually how consumers find out. There's some pivotal event that often you can't tell in advance that this is something that people care about. But in Russia now, apparently, this is a big thing. Like, people really worry about this. People like switching off their profiles. And I remember something similar happening in the past. I remember when my mom, who's a medical doctor, the least technical person you ever met in your life, came to me to talk to me about which virus scanner to use. This is my mom discussing with me the preferences of like different virus software. And I found it very startling that my mom knows what a computer virus is and then knows what a virus scanner is. And I think she knows because like 15 years ago or so, there were like major incidents with computer viruses, and the internet was down for a day, and we couldn't send email. And technology had become ubiquitous enough, and it had become painful enough if it fails or something goes wrong that like my parents noticed if it did. I'm pretty sure this is exactly how all of us are going to learn how consumers feel about privacy if we get it wrong. One day, someone is going to make something that's going to like hurt people's privacy, and all of a sudden, consumers will respond to it. So this is really this interesting duality where technology really allows us to do amazing things with it that were completely impossible before, but also it will completely change basic expectations. We will create new problems. People didn't know that privacy could be a problem to this degree. I spent many years at Mozilla trying to like sell people privacy, and they're usually not buying. People like, and nobody really likes buying privacy-related stuff. People like to like buy like nice things that like work for them, not really think about the scary stuff. They only start thinking about the scary stuff when it goes wrong, but then it can be very life-changing. Now let's talk a little bit about the data behind this. There's a quote from Greg Duffy, the founder of Dropcam, where in 2013 he talked about how Dropcam already takes in more video than YouTube. And this is 2013, and these guys have been selling their products pretty well since then. So the amount of data that Dropcam is taking in from inside people's home is dramatic. And if you think about the example I showed on the slides on training of these networks, it's a treasure trove, right? Like, how do I build a neural network model of like figuring out, for example, whether a human sits on a couch or not, which would be really great to solve my light problem I motivated in the beginning. I would have to come home and sit on my couch, and I want my house to figure out what kind of light do I want. Do I watch TV, or do I read something? Different light conditions needed. I don't want to get up for that. My house should figure this out. The software to write that is easy. Getting the data of humans inside the house doing stuff, that's very hard, except if you happen to have more data than YouTube from inside people's homes because you're running a service like this. So this is fantastic. Essentially, products like this will make it possible to build even better, orders of magnitude better products that do all these great things because you have access to all this data. The downside is that the amount of sensitive data all of a sudden you're accumulating in the cloud is absolutely scary. And don't just think about security here, also think about some of the legal implications. I don't know how many cameras Dropcam has, but I would estimate it's probably close to 1 million cameras that they operate based on a statement they made on YouTube. And just imagine the draw this has for governments. Actually, you don't have to imagine this. James Clapper, of NSA fame, already said that the NSA is very keenly interested in the IoT space. I can see that, right? Like, you're looking for a bad guy. Like, can we briefly look in the house of every American consumer just for a minute? So again, this hasn't happened before. This was not feasible in the past. Like, let's just like at the same time look into every house in America and see if there's someone else we're looking for. But now essentially it will be very soon. And even if you think, oh, I'm not going to buy a Dropcam, I'm fine. Like fire alarms and like smoke detectors and your Tesla is going to rat on you. So essentially, you can't escape this stuff. It's coming. So, of course, there's also parallel developments happening on the smartphone side, which I mentioned earlier. The amount of compute we get today in the smartphone supply chain for a couple dollars is really amazing. So Snapdragon 650 is kind of like a mid-tier-ish mobile chipset. If the internet is to be believed, it costs about $20 without a radio. It has around 200 gigaflops of compute. That's a lot of compute. I remember when I was a student, like, asking for time on a cluster that had less compute than that. So it's totally nuts. And at the same time, we are getting better and better at figuring out how to run neural networks on this kind of compute budget. So the kind of networks that get close to human perception in certain areas or in certain domains easily run in this amount of compute. And there's lots of advances happening all the time around binarization and other techniques that might make this even an order of magnitude or maybe order and a half magnitudes faster to run. So it's becoming really amazing what you can run locally. The problem, of course, still is the training part. The training part, we cannot apply the same techniques to. I can now run it forward to recognize a picture locally, but then how do I train this? How do I train this sort of a data trove? The other piece that makes training very hard is that the compute difference between a server environment where you're training these networks and the mobile environments where you might use the networks is still very, very large. So you still probably have at least 100x delta of really advanced silicon you can use for training in a cloud that you can use on a mobile side. There's a couple of promising things happening. Facebook recently talked about how they do training on a CPU using clusters. Essentially, they train separately on multiple machines and aggregate the training results. They published this at a fairly small scale. I think they talked about 20 or 30 machines that they aggregate over. But in theory, right, there's enough imagination, they could do this at scale. Millions of people could locally train their networks and maybe aggregate this together. Unsolved research problem. As far as at least I know right now, training the cloud right now is really the only viable alternative. Not necessarily because of compute only, but simply because the data is not there. The last part I find very intriguing about doing the local processing is that you have the chance to locally turn data information, and then essentially that gives you the chance to completely locally encrypt everything. One feature we are building into our product is that we do a bunch of local processing and facial detection, who is home, and we allow you to end-to-end encrypt this completely, so our cloud doesn't have any access to the video feed. Essentially, a smartphone and the device in the house exchange a cryptographic key, and the device in the house can tell who's home and sends you a notification, hey, someone is home. And because we're not doing the processing itself in the cloud, we can very easily do this completely securely. So if the NSA ever comes to us and would like to see the video feed, I can't help them. I can give them an encrypted one and then please come back to the quantum computer if you would like to know what's going on there. So that I think will give us a chance to save some of the things that are going really wrong right now. Some of the scary stuff I motivated earlier is not just theory. This is a picture from a search engine called Shodan. Essentially, that search engine tracks and scans the network for poorly configured IP cameras. So this is some person's home that the camera captured. This is not theory. This stuff is happening right now. And the products you're buying right now are really, really scary in parts. Like baby monitors, for example, very, very scary. Many of them, you can find lots of them on Shodan. All right, I want to have time for at least one question or two, so I'll wrap up here quick. But essentially, I tried to show today to you that there's this amazing things happening around what we can do locally with compute. And we're at the point where essentially we can do really great things processing vision locally on the device, but training is still a big issue. And I would really encourage everyone to think very deeply around the implications of the kind of society we are building with the technology that we are building. Some of this stuff is irreversible. If we all get a camera sensor into a house and process all that information in the cloud, the societal implications will not be reversible. Once we build this technology, it will be used. At the same time, I don't have the alternatives for you. I cannot tell you, if only we would do this other thing, because this other thing doesn't exist right now. That's one of the most exciting things for me working in this space, is that some of this stuff is really the very leading edge of what we're trying to understand how this stuff is going to work. So hopefully, over the next couple of years, when we meet again here next year, we will know a little bit more about how we can solve some of these problems. Thank you very much.
Thank you very much, Andreas. So if there's any questions, again, please use the mic at the end. But a quick question is, do you see the industry driving some clear resolution to the privacy issue, or is that something that legislation is going to have to drive? What's your thought on that?
I generally don't like relying on governments for anything. That usually doesn't go well, especially when it comes to my own personal privacy. So one of the reasons I founded this company is that I'm not happy with the trend that we are on, and I don't believe the government is going to fix that for us. I think it's been on us as industry to solve some of these problems. There are some players in the field, outside the field that we are in, who have been doing that very well. If you have been watching what Apple is doing right now around end-to-end cryptography on their phones, they're essentially trying to define a new milestone, how your privacy works on your phone, before the government gets around to legislating that. And then by the time the government gets around to it, essentially, some things will already be defined. I'm trying to do something very similar in our space, is that we should try to build systems that are hardened against these kind of problems. And then essentially we are setting a much better base for the negotiation with legal authorities around things like legal intercept and so on.
Great, thank you. And I think we've got one question over here we have time for.
So as deep learning compute moves more and more to the devices, what kind of hardware requirements do you envision? Hardware requirements on the platform?
Yeah, I think the short answer would be already the smartphone hardware stack is so advanced just because of the scale of it and the price pressures and some of the marketing pressures behind it. Some of that stuff that's coming out of that supply chain is a dream. Like, we happen to work with Qualcomm Silicon, and that's the example I used on the slides, and it's like pretty much everything we could ask for right now. We will always take more, and it's going to be better, and the GPUs right now are not as optimized as some of the server-class GPUs for the tasks, so I expect that stuff to be fixed over time. But as far as raw computational power goes, it's 200 gigaflops. Like, you can do a lot of stuff with that. So I don't think performance is necessarily a problem. You will see essentially probably an order of magnitude optimization over the next 2 years or something like that. But today, I think the software is much more the problem than the hardware. The hardware is already there, essentially. It has existed for several years. It's really on software people like ourselves to provide the necessary software to take good advantage of all the silicon that the smartphone space defined for us.
But there's a trend of off-chip network accelerator chips. Do you see a future of that coming more and more on the devices?
Yeah, definitely. I mean, there will be probably in the future dedicated silicon for this that is even better by orders of magnitude. The reason I'm hesitant to kind of bet on that is that there's so much advances happening still on the software side. I saw recently a paper that was, actually I forgot who it was from, but they did a trick called binarization. They turn a network into essentially, instead of a floating point number, into 1 bit. So they compress the size of the problem by 60x and the performance also by 60x. They compress the size by 32x and performance by 60x. So just by making better software, they made it 60 times faster. So I want to see essentially that curve level out first. And then I can tell you whether we need like magical silicon. Right now, I think we need just software people like ourselves need to do a better job taking advantage of all the amazing hardware that exists today.
Thank you.
Thank you.
All right. Thank you very much, Andreas. And you've helped me be cautious about my Samsung TV.